Chapter 3, Exercise 22. Should the following are correct for any sets? A is a subset of B implies that the image of F under A is a subset of the image of F under B. B, the image of the composition of F and G under A is equal to the image of F under the image of G under A. And C, the restriction of Q to A union B is equal to the restriction of Q to A unioned with the restriction of Q to B. These are pretty simple. Nothing too out of the ordinary. It's just relying on the definition. So let's get started. Right, so let's assume that A is a subset of B. And now let's suppose Y is in the image of F under A. Given the definition of the image of F under A, there must exist some X in A specifically, such that X comma Y is an F, right? But since A is a subset of B, then X being an A implies that X is in B. So X comma Y is an F, and we also know that X is in B. Thus, Y must be in the image of F under B, right? Therefore, the image of F under A must be a subset of the image of F under B, and it follows that since we assume that A is a subset of B, that this is an implication that is true. There we go. Right. Now let's go for part B. B says this. The image of the composition of F and G under A must be a subset. The image of F under the image of G under A. Right? Oh, no. It says these are actually equal. So let's do this. Let's do both sides. Let's suppose Y is in F compose G, image A. Then there exists some X in A such that X comma Y is in F compose G, right? Thus, what? Oh yeah. Now, if XY is in F compose G, then there exists some T such that XT is in G and TY is in F. Right. So we have that XT is in G and X is in A, which implies that T is in the image of G under A. Then we also have that TY is in F and T is in the image of G under A, which implies that Y is in the image of F under the image of G under A. So, composition, the image of the composition must be a subset of the nested image. And now let's go backwards. Let's suppose Y in the image of F under the image of G under the image of A. Then what? There must exist some T in the image of G under A such that Ty is in F, right? And then since T is in G image under A, there must exist some X in A such that xt is in G. One thing you can see is that our implications go this way, right? If you want to make this shorter for yourself, all the implications go this way. But these are all if and only if statements, right? So they are actually reversible, and then you can just decide to like leave it at that. And this should show like that these two sets are equal. But I like to work in one direction only. I think it's easier. Right. Okay. Thus, what do we have? Xt is in G and Ty is in F, which implies that there exists some T such that xgt and tfy so x comma y must be in the composition of F and G. And thus we have that x comma y is in the composition of F and G, and x is in A, meaning that x comma y is in the image of the composition of F and G under A. And thus we have that our set, our right hand side is a subset of our left hand side. And now we can conclude that the two sets are actually equal. There we go. And now C, that Q restricted to A union B, is equal. Q restricted to A union Q restricted to B, right? So let's suppose that x comma y is in Q restricted to A union B. Then x comma y must be in Q and x is in A union B. So x is in A or x is in B, or x is in A and x is in B, right? If x is in A, then x, y is in Q, and x is in A, which is the same as saying that x comma y is in the restriction to Q, restriction of Q to A. Oh, sorry. Oh, yeah. No, that's the direction we're doing. If x is in B, then the same thing happens. Oh, right. I forgot. Unioned with Q restricted to B. Okay. Because, of course, Q restricted to A is a subset of Q restricted to A union Q restricted to B. And the same thing happens with Q restricted to B. Okay. X comma y must be in Q restricted to A union Q restricted to B. If X is in A and X is in B finally, both cases apply. So, what? X comma y is in the restriction of Q under Q to A union with the restriction of Q to B. No matter what. And thus, restriction of Q to A union B must be a subset. Restriction of Q to A union the restriction of Q to B. Now let's do the final part of this exercise. And I'm running out of time. Let's suppose X comma y is in Q restricted to A union Q restricted to B. Then again X comma y is in Q restricted to A, or X comma y is in Q restricted to B. Or both. If X comma y is in Q restricted to A, then X comma y is in is in Q, and X is in A. Now X is in A implies that X is in A union B. So X comma y is in Q and X is in A union B. Meaning that X comma y is in Q restricted to A union B. Now similarly, I'm just going to keep this with shorthand notation. It implies that So x comma y is in Q and x in A union B, which is the exact same thing as saying Q restricted to A union B. Okay. If both x comma y is in the Q restriction of A and x comma y is in the restriction of Q to B, then clearly both of them apply, both cases apply, and thus Q x comma y is in Q restricted to A union B. Right. And now finally x comma y is Q restricted to A and B no matter what. Thus, Q restricted to A union Q restricted to B must be a subset of Q restricted to A union B. And now we conclude that these two sets are actually the same set. And there you go. And that's all of this exercise for you. Oh, forgot to add this annotation. Alright, hope this was helpful. I'll see you in the next video. Bye bye.